Welcome to Matt's Workshop. This is the second episode in a series of videos I'm doing on the rotary axis attachments that I've got from Cloudray Laser. In this video we'll look at the Chuck Rotary Axis. So we'll look at how to set up the Chuck Rotary Axis in the software, where to find the settings that need to be changed, such as the steps per revolution and the diameter of our workpiece. The circumference is also important because this will be determining the height, the maximum height of our y-axis, so that it doesn't overwrite onto the previous cuts that we've done. So this is the Chuck Rotary Axis. We have jaws that hold the workpiece in place, and the way that you do that is simply put the piece in there and turn with the chuck key until it grips. Now this can be quite damaging on the material and can slip out quite easily. So I've actually developed a method of holding pieces in place on the Chuck Rotary Axis, and I'll show you how I designed that later on. So the controller that I'm using for this video with the Chuck Rotary Axis is the Ruida RDC6445. Now Ruida's software that comes with it is RDWorks, so I'll show you how to back up settings and make changes in the software using RDWorks, but I'll also show you how to do it in Lightburn. If you have a different controller than this, like a Top Wisdom or Troken controller, the settings that need to be changed are the same. You'll just need to find where they are on your controller and in your software. But if you do have one that is compatible with Lightburn, that makes it quite easy because Lightburn settings will work between several different controllers. So this is RDWorks. RDWorks is the software that comes with the Ruida controllers, and it's also the software that can talk to the controllers and back up settings. So before we do any rotary work, it's always a good idea before we change settings to have a backup file. So this is just how to back up the vendor and user settings. So we go to vendor settings, put in the password RD8888, and first of all we read that information from the controller. Now we want to do is save all the vendor settings as a backup file. I've called my file vendor backup, and we press save. So that saves everything onto that file, so in case we change something and want to go back to it, we can always open that file and re-import those settings back to the software and then write it back to the controller. Another tip while we're here is looking at the y-axis. In the last video I showed you how to turn off the enable home on reset for the y using the controller. Here in the vendor tools we can untick enable home and write that to the controller, and that does exactly the same thing. So now that we've set that, the other option is the user settings. We want to back those up as well. So we just need to scroll down the side here. We read the information from the controller and press save. I've called this file user backup, and we'll save that file. So these parameters, if I make changes, forget what they are, I can always open that file and import them again. Okay, so to enable the rotary axis, what we need to do is go to the user tab, other, and scroll down to where it says rotating. We've got rotating here, we need to turn that on, so we say yes. So for the rest of these values here, we need to actually use a calculation, and that calculation is this equation here, which is circle pulse, which is also your steps per rotation, and that equals the gear ratio multiplied by the diameter ratio, which is then multiplied by the pulses per revolution. So the gear ratio of Cloudray Laser's rotary axis is actually 2:1, and being a Chuck rotary, the diameter ratio is actually 1:1. So we've got a gear ratio of 2, a diameter ratio of 1. We now need to find the pulses per revolution. Now that can be found on the y-axis driver, and now we look at the dip switches on the side here, switches 5 to 8. We want to look at the settings of those and then refer that to this chart that's printed on the y-axis driver. If this is not printed on your driver, you should be able to find this chart in your user manual for your axis driver. So we can see here for my driver that it has a pulse revolution of 5,000. So now using these figures we can calculate the equation. So 2 times 1 times 5,000 equals 10,000. So that's our circle pulse, or steps per rotation. The only other thing we need here is our diameter, and the diameter will be the diameter of the chuck, which is 80 millimeters. Once you have these figures all entered in, then it's possible now to write that to the board. Okay, so we've checked our diameter, and we have a chuck diameter of 80 millimeters. We've also set our circle pulse, so we're going to do a test. So to do this test, I'm just going to pop some tape here as a mark, and on the other side we'll pop another piece of tape there as the lining up mark. Okay, so now what we want to do is use this option underneath here that says test, and this test will run at 50 millimeters a second. You can change it if you want to. So we're going to see whether the 10,000 steps per circle pulse is actually one full revolution. So we press test and we say OK, and the rotary will go around and it should line back up perfectly, which it does. Just an example, I just want to show you here, if we had our steps out, so if we had this at say 9,000 and we wrote that back to the board and we did that same test again, we should see that the mark stops short. And that's a way that you can see whether you need to adjust it slightly. If it was out by a few millimeters, you could adjust your circle pulse so that it met up to where you want. So we've got it back where it was, and we'll pop it back at 10,000, and making sure that we write it back to the board and then testing. Another important setting to change when you're using a rotary attachment on your laser machine is the idle speed. On the Rowita controllers, the idle speed is the speed that the axis will move between cuts, and also the speed at which it will return to its point of origin when the job has been completed, or if you finish by pressing stop. If you got it set at 400, it can cause quite a lot of inertia. The piece may fly out of the rotary attachment, and you don't want that to happen. So when I'm doing rotary work, I like to set this down at about 50 millimeters a second. I'm going to quickly demonstrate. I've got this line here that's 20 millimeters a second, and I still left my return speed at 400. So using a chuck rotary attachment, if I start the job at 20 millimeters a second, at the end of the job it will return at 400. So if we reduce this now to say 50 millimeters a second and write that back to the controller board, if we start this job now, then you'll notice that if I press stop halfway through the job or at the end of the job, it will return at a more controlled speed. Okay, so now what we need to do is put the rotary inside the machine. So following the instructions from the previous video on connecting up the aviation plug that's down here, we've got that all connected, and now we need to lower the bed far enough so that the rotary will fit in. Okay, so once you've got it positioned, this is now the y-axis, so the y-axis rail is free moving, it's not being held by the stepper drivers. So we can just move it to where we want, and then if we open up the chuck jaws, we can position our piece. Now there are other methods of positioning and holding material in on the chuck. The chuck is quite aggressive on the material, so it can actually cause it to break, mark it, etc. So just move the tailpiece up and lock it into place as well. So now what we need to do is find our focus point, so we can focus that on the part of the job that we want to engrave or cut. So I've focused that there, that's good. Now what we also need to do is find the center line or the center axis. On this chuck I've marked the center axis, so we can move our x-axis over there and just position the rail until it's on that and we know we're centered. And then bring it back to where we want and press origin. Now when you're working with the rotary, we need to know what the diameter of the workpiece is, and that gives us the circumference, which works out to our maximum height or length of our job. So this is a 77 millimeter diameter bottle, so we're going to have a look at the software. So if our diameter of the bottle is 77 millimeters, then we go to user, go down to the diameter and put in 77 millimeters. Once you work out the circumference for the bottle, then you use this as your maximum height. So the bottle at 77 millimeters has a circumference of 241.9 millimeters. So we just put that in there. I'm actually going to cut this one on the laser. Just remember before you start that you need to write that setting back to the controller board. So we can see here that our test piece went all the way around. The start line finished up with the end line and then back again. So we've got our settings set accurately. We're going to try with something a bit bigger. Okay, so with this next jar that I'm using, it has a diameter of 127 millimeters. So what I need to do is click in here, back under the user, under rotating, and change the diameter 127 millimeters. Now what I need to do is work out the circumference of the jar, and I've worked the circumference out at 398 millimeters. So I put that 398 in here just so that we adjust our rectangle. So this is the top of the y-axis, the circumference of the jar back to the top again of the y-axis and returning. So let's just run this test and see how accurate we are. But before we do, something we need to do is make sure that we write this 127 millimeters to the control board. So what I've done for this test is I've just put the tape on the jar and I've marked it. I'm not actually going to cut this, but we can watch the red dot go round back to that location and then return back again. So I've got the laser off and we're just going to start this now. So as we can see, we went all the way around the jar back to that point and then around back to the origin again. So we've been able to set it up successfully by entering in the diameter in the settings as well as the circumference as our maximum height. We're going to have a look now where we can find these settings in Lightburn. So first of all, we can have a look at the machine settings. So under Edit, go down to Machine Settings, and this will load the user settings from the machine. So one of the settings we changed previously was the idle speed. That can be changed here. So we could set that to 50 millimeters a second. The other thing that we can look here is Enable Rotary. We can turn it on and set the value in there, which was 10,000. And the diameter for the test piece was 80 millimeters. And we can write that to the controller. And then when you're finished, click on OK. The next thing we look at is Tools and Rotary Setup. Now we've enabled the rotary, so it'll come up here as a tick box and you choose what type of rotary attachment you have. In this case we're using the Chuck version and we have steps per rotation which we've set at 10,000 steps per rotation and the object diameter of 80. The good thing with Lightburn is that if we change this to 127 diameter, it automatically calculates our circumference for us. So then if we had a piece that was 127 in diameter, we know that our maximum height will be 398 millimeters. And now we click on OK. There is another option which you can turn on down here, and that's Enable Rotary option, where you can turn it on and off. Where you get that is in the settings, and we go to here where it says Rotary Enable on main window. And when we click on OK, we'll see that we have this switch box here which we can turn on and off for the rotary attachment. So the thing I notice is that the Chuck rotary attachment has this cone or point that points into the bottom part of the workpiece. So the cone is not very accurate at holding the workpiece. You can put a mark on your job to get the absolute center, but on very hard objects it doesn't pierce and it doesn't hold it very securely. On the other end we have the Chuck, and the Chuck has the teeth. So if you have teeth putting pressure on the glass, then you could crack the glass. So I've developed this little holder which has a soft padding on the inside to help it hold together and has got a lot of friction there. So the first thing I did was just draw up some circles in Lightburn. These are 100 millimeters in diameter with a 4.75 millimeter internal hole. So these are going to form the face and the base plate for my rotary holder, and I'm cutting that out of 3 millimeter acrylic with some 3M adhesive put on it. So the next part that we need is a 50 millimeter disc with a 10 millimeter internal hole, and we'll cut that out of the same material. So get this packing type material, and we peel off the 3M adhesive. We want to stretch it out as far as we can, push down, do this for both pieces, and then trim the excess off. You can use this foam, or you can use rubber, anything that's got a bit of friction and grip to it. Now this is the other piece that we cut out. This piece here is what ends up being held in by the chuck. You can make this out of a thicker material if you want to. So grab a screw, poke it through. Now it is a tight fit. Design that way so it doesn't slip. So you just adjust your center hole to the size screw you're using, and the other piece that we cut out before with the adhesive backing goes around the outside edge of that screw. Again, a nice central fit so that we know it's all dead center. So now what you do here is you just cut out pieces that match the material you're using, and you screw them on. So if you're using a 40mm like this one, this is a 40mm, you put that on, put it on there for security, and then on the other end this points on here. So let's go and assemble it up. So I've got a jar here which I measured up to that piece in there, so that fits nicely in here on that edge, and this piece here gets wedged into or held in place by the chuck. So tighten the chuck down. So the wing nut ends up on the inside of our workpiece, and then we pop this on here. The backing plate goes at the back. Line it up with the center hole, and then lock it in place. And now we have it nice and secure inside between those two friction pads. So the good thing about these, like I say, is that if you didn't want the big one on there, you wanted a smaller one, any size, you just cut one to suit the piece of material or the circumference of the inside of the work that you want. That's my design for that one. Okay, so the last thing I want to show you before we finish up is the teeth that can go in the chuck. So if you have a look at the set of teeth, these ones clamp inwards and these ones go the other way and they will clamp outwards. So they're all numbered. So if you have a look on the inside, you will see that it's got some numbers on there, and this one has a number 2 at the beginning. We have a number 1, so 1, 2, and this will be number 3. Now these are specifically geared for the inside of the chuck. So to remove the other ones, we just rotate them outwards. So pull the first one out, and it's a number 2, and this one here is number 3, and number 1 will be the last one that is released, number 1. Now number 1 needs to be the first one that goes in. So this is number 1. So if we actually turn the chuck around so that's up at the top so we can see it, I'm going to zoom the camera in and we're going to have a look at that. So we can see we have a number 1, a 3, and 2. So the way that so that's the order that they need to be assembled. So number 1 needs to go in first. So to put them back in, we grab number 1 and we slide it in the number 1 slot, and we turn it clockwise, so just enough for it just to grab and then you can't pull it out. You don't want to turn this too far or they won't be synchronized. So now what we need to do is rotate it for the number 2 and do the same for that one. So pop this in and rotating it clockwise just until you can't pull this out. So now we again do the last one. So number 3, slide it in, turn it clockwise, and now you should be able to just continue to turn, and you'll know that you've got it synchronized and all correct when they reach the edge of the circumference of the chuck. They'll all be flush. If you haven't got them in correctly, they won't be synchronized, so they'll be all stepped out and jagged, so they won't be able to grip properly. So you've got the outward gripping teeth and the inward gripping teeth, so just remove them the same way. Alright, so let's just do one quick project from start to finish. So we've got this jar that we've been working with, 127mm diameter, and we're going to set up a job in Lightburn to do this. So I want to etch this onto a jar for a chocolate stash. So what I'm going to do is set it up. So we enable rotary, and then we go into Tools, Rotary Setup, we select Chuck, and we put in the diameter of 127. We jump down here, we grab the circumference, and we put that into a frame that gives us an idea on what the height of the workpiece is going to be. So we're putting in there the circumference. So that's now the height, which is our work area, and we only want the work length to be approximately 120mm. So we're changing the width to 120mm. So that gives us the circumference. So what we're going to do is rotate this one. So we'll just take it round about 90 degrees the other way, and we'll pop that in on our jar. So we're going to put it down the bottom here. Now I've already set up my origins, so machine origin and job origin, so that the rotation's in the correct order for my machine. So we'll just pop that there, and it gives us an idea that it will fit in. So we know that it's going to fit in the width of the x-axis, and it's going to take up only a portion of the y-axis, which is what we want. So we can remove the outside rectangle. We don't need that, and we don't want it to cut. We just need to make sure it was going to fit in the space required. And now we've set the job. I'm going to run this now on the machine. So here we have the finished product. Don't touch my stash, and that's specifically a notice for the kids and the wife to leave my stash of goodies alone. Thanks for visiting Matt's workshop. We had a look at the Chuck Rotary and how to set it up, and also looking at the settings in the software. This little attachment that I made is quite helpful for holding pieces in the Chuck Rotary. If you have other ideas on how you hold workpiece in the Chuck Rotary, you can always leave comments below, or head over to the community page on my channel and start a discussion there, where you can also post pictures and different ideas that you have. It's always good to share and disseminate that information. So if you want to grab one of these for yourself, if you don't have a rotary attachment, I'll leave a link to Cloudray Laser's website in the description below. If you like the video, give me a thumbs up, and if you haven't already, press the subscribe button, and if you put the notification bell on, you'll be notified when I release new videos. In future videos, I'll be looking at the wheel rotary attachment, as well as the pros and cons of both, and then later on we'll look at doing some engraving work and projects on these rotary attachments. And until next time, take care. Cheers.